material mo dito, ang reference material natin will always be air. Specific gravity is equivalent as well to the specific weight of the fluid divided by the specific weight of the standard material. Bakit? Kasi yung specific weight, ang formula nito is equivalent to density ng materials multiplied by the acceleration due to gravity divided by the density ng standard material multiplied by acceleration due to gravity. So, they'll just cancel each other out, leaving us again with this equation. Density ng fluid divided by the density ng standard material. So, for standard values ng specific gravity, water will always be 1 kasi density ng water divided by the density ng standard material, which is still water. So, that will leave us with 1. Seawater, 1.03. Mercury, 13.6. Bakit natin kinukuha si seawater? Kasi minsan yung fluid natin is, we uses seawater. Ginagamit ito sa mga planta na malapit sa dagat. Ang kinukuha natin tubig dito, or yung tinatapon natin tubig, papunta sa dagat lang. Then, specific volume. Specific volume is the inverse ng density, kung makikita natin dito. But it is defined really as the ratio of the substance's volume to its mass. Kaya naging inverse siya ng density kasi ang kanyang formula is volume over mass, while density is mass over volume. So let's just inverse the density and we can have the value for specific volume. So for the fluid properties, iikot nga lang to sa mass, sa volume, sa specific weight, at sa acceleration due to gravity. So we already defined ano ba ang meaning ng fluid, ano ang concept behind the fluid. There are two types, liquid or gas, which are incompressible and compressible. Later, makikita natin ang importance kung bakit kailangan ma-determine natin if the fluid is incompressible or compressible. There's an equivalent equation for that when we go through na sa fluid flows in pipe. Then yung fluid properties, iikot lang siya sa specific weight, mass, density, specific gravity, and specific volume. So since mass and volume, yung nabanggit natin dito kanina, kailangan natin malaman yung common conversion. Kasi kung ano ibigay sa problem, halimbawa, binigyan tayo ng English unit, so in English unit din natin siya dapat masolve. If binigyan tayo ng metric unit, then dapat metric unit din yung masolve. Or kapag binigyan tayo sa problem ng mixed unit, is either English or metric, then we need to solve the problem sa kung anong hinihingi. If hinihingi is in metric unit, then we need to standardize or we need to convert every given into a standard format. If hindi nga tayo in feet, then we should provide the problem in feet or the solution in feet. So common conversion, we need to remember this. 1 kilogram is equivalent to 2.205 pounds or 2.21 pounds. Usually, ginagamit talaga ito sa kilogram and sa pounds. Makikita niyo yan in every problem sets or in every terminologies, mababasa natin yan. Kasi ounce, bihira lang naman, pero sige lang, 1 pound mass is equivalent to 16 ounce. Si slug, bihira din naman natin siyang makasalubong, pero let's memorize it kasi nga baka makita natin siya sa problem, so much better, malalam na rin natin. So 1 slug is equivalent to 32.2 pounds. 1 ton, this is in metric ton or in metric unit, even though marami tayong klase ng ton. Si metric ton is in metric unit or SI unit, equivalent siya sa 1,000 kg. Then short ton, this is in English unit, iba rin ang value niya, is equivalent to 2,000 pounds. Then 1 long ton, hindi na siya ginagamit, superseded na to, pero let's see, baka lumabas na siya sa problem, so let's just memorize it na din. So it is equivalent to 1,240 pounds. For the volume naman, gallon, liter, cubic meter, and feet, commonly used talaga to. So even the barrel. So makikita natin to and we need to memorize how to convert it. So 1 gallon is equivalent to 3.785 liters. 1,000 liter is equivalent to 1 cubic meter. Then 1 cubic feet is equivalent to 7.48 gallons, while 1 barrel is equivalent to 42 gallons. There are many other conversions pa or other units na ginagamit, pero ito yung common lang na nilagay natin dito. So, classification of fluid machineries. Kung kanina dinefine natin si fluid, ngayon naman yung machineries involved naman. This is just an overview. The following will just be an overview kasi we will discuss this in detail once na according to the respective week na may discuss natin yung type ng fluid machinery. So, fluid machines are defined as those machines which convert either hydraulic energy or water energy, kaya siya energy possessed by water, into mechanical energy, which is further converted into electrical energy. So those types of fluid machinery, pwede natin consider si water turbine, kasi si water turbine, siya yung ang nagpapagalaw sa kanya or kumukuha siya ng energy dun sa energy possessed by water. Then, kino-convert yung mechanical energy na yun, yung rotating parts na yun, like impeller, naka-couple siya sa generator. Kaya so those rotating parts will further convert it into electrical energy. Unlike sa pump, in which converts the mechanical energy ng pump into hydraulic energy. So, in contrast kasi sa kay pump, si pump ang nag-provide ng input or ng work input dun sa fluid para mapataas or para magkaroon ng additional energy yung fluid na dumadali dun sa pump, na dumadaan sa pump. So we have classifications of fluid machines. First is the classification based on direction of energy conversion. So later, makikita natin sa formula kung ano yung ba ibig sabihin ng direction of energy conversion natin. Next is classification based on the principle of operation. We also have video link later. Papanood natin kung ano ba yung iba't ibang type ng fluid machinery based on their principle of operation. And third is classification based on fluid use. So pwede natin i-classify yung fluid machinery into direction of energy conversion, based on the principle of operation, and based on the fluid use na specific na machinery natin. So classification based on direction of energy conversion, maali lang naman to sa sa turbine, wherein ito yung nagre-receive ng energy from the fluid itself, and sa pumps and compressor or fans or blower, wherein ito naman ang nag-i-input ng energy sa fluids natin. So by definition, the device in which the kinetic or potential energy held by the fluid is converted in the form of mechanical energy of a rotating member known as turbine. So kino-convert ng turbine ang kinetic or potential energy ng fluid, then tinatransfer ito as a mechanical energy or a rotating or a rotating energy. Then yung rotating energy na to nakakouple sa, or yung rotating part nito, rotor or impeller is nakakouple sa generator, which will further convert it into electrical energy. So, based nga daw ito sa direction ng energy conversion. So, si fluid ang nagpro-provide ng energy sa rotating member ng turbine, which is impeller or the rotor. While the machines, on the other hand, where the mechanical energy from the moving parts is transferred to a fluid to increase its stored energy by increasing its pressure or velocity, are known as pumps, compressor, fans, or blowers. Well, unlike naman daw ito sa pumps, compressor, fans, or blower, wherein the mechanical parts nung nabanggit natin na machines na yon, sila yung nag-i-increase ng stored energy sa fluid para mapalakas or mapataas ang pressure dito depending on the application. Per pumps, usually to transfer fluids from one place to another para may elevate natin yung fluid kasi hindi naman tataas ng kusa yung fluid niya. Kailangan natin ng external energy, external mechanism para ma-increase natin or matransfer natin yung fluid from one place to another. While compressor, kinocompress natin yung air, napataas natin yung pressure, then binabato natin to sa kung ano man ang purpose niya. For example, for industrial use, it can be used for cleaning purposes, tagalinis na ng equipment, or it can be used or assist in painting. Kasi in painting, we usually use the air gun kung saan yung hangin nagmi-mix dun sa pintura natin, sa liquid paint natin, paint material, then ito yung ipinabato sa substrate or dun sa material na pinipinturahan. While fans or blowers, hindi masyadong ini-increase ito yung pressure kasi yung purpose naman niya is not to increase the pressure of the fluid or ng gas or ng air. Ang purpose naman ng fans or blowers, usually nakikita natin to sa mga HVAC mechanism natin para lang naman to mapa-ventilate or mapa-condition natin yung room. So it doesn't require an increase in pressure kapag gumagamit tayo ng fans or blowers. So classification based on in principle of operation naman to. So kanina, direction of energy conversion, nahati lang siya or we just divided it into turbines and pumps, compressor, fans, or blowers. So it's turbine against pumps, compressor, fans, or blowers. Now it will be a classification based on principle of operation. So meron tayo ditong term na ginamit which is the positive displacement and the other one is the rotodynamic machines. So for the positive displacement, the machines whose function So the machines whose function depends essentially on the change of volume of a certain amount of fluid within the machines are known as positive displacement machines. We have a video of this later. The word positive displacement comes from the fact that there is a physical displacement of the boundary of a certain fluid mass as a closed system. So literal daw na may positive displacement or may displacement na nagaganap dun sa loob ng piston. This principle is utilized in practice by reciprocating motion of a piston within a cylinder. We will show it later. Piston within a cylinder while entrapping a certain amount of fluid in it. Therefore, the word reciprocating is commonly used with the name of the machines of this kind. The machine that develops the energy of the fluid from the mechanical energy is known as a reciprocating pump or reciprocating compressor. So we have different types of positive displacement machines or positive displacement pumps. It's either the rotary vane pumps, watering pumps, rotary piston pumps. We will dwell into that when we go into the topic of pumps. Progressive cavity pump. But for now, I'll just show you a basic principle kung paano ba gumagana ang positive displacement machines. As I said earlier, meron lang restriction yung aking ginagamit na laptop. Hindi niya kaya mag-share ng file. Rather, ang capability talaga is to share some screen. So yung video na to, wala kayong maririnig na sounds, pero naka-subtitle naman siya. So maintindihan pa rin natin. Then, if needed explanation naman, I can pause it and explain in between. So let's just watch how a positive displacement pump works or yung fundamental principle ng positive displacement pump. So as you can see in the video, literally there is a displacement na nangyayari sa loob ng ating cylinder. So once nagubalaw yung piston, there will be a suction, there will be a nagkakaroon ng suction dito, so nahihigop dito yung tubig. Then dinidisplace din siya palabas going to the delivery valve. So kaya siya tinawag na positive displacement pump kasi talaga meron or literal na nagkakaroon ng displacement within the cylinder caused by the movement of the piston. It will explain in this i-explain sa video na to yung iba't ibang klase ng reciprocating pump. Pero for now, let's just cut it out kasi overview lang naman ang kailangan natin ipakita sa ngayon. So another type of or another classification of fluid machinery based sa kanyang operation is what we call the rotodynamic machines. Kanina, we used the term positive displacement. Ngayon naman, we will classify them as rotodynamic machines. So rotodynamic machines are machines that depend basically on the principle of fluid dynamics. They are distinguished from positive displacement machines requiring relative motion between the fluid and the moving part of the machine. So we have two types of positive displacement. Two types of rotodynamic. It's radial flow and axial flow. We have also another type I will show in the video later. This is called as mixed flow pump. So ano ba yung parts ng ating rotodynamic machines? Ma-identify natin na siya is rotodynamic machines or madi-distinguish natin if the machine has a rotor or impeller. Kagaya sa fan, there is blades na ginagamit ng fan. Same goes with turbines. So they are called as rotodynamic machines. Rotor impeller is a rotating element ng machine usually consisting of a number of vanes or blades. So best example nga is yung ating electric fan or yung fan and yung ginagamit sa ginagamit sa air turbine. Then stator, ito yung fixed part ng machine or usually ito yung enclosure o yung cover nito. Yung cover ng rotor or ng impeller. Let me show you again another video to describe what is a rotodynamic machine. Okay, centrifugal pump is a type of a rotodynamic machine. It can be classified or it can be categorized as a type of or sample of a radial flow pump. As I said earlier, madidistinguish natin ang rotodynamic machines based sa kanyang parts. So, ang binigyan natin example is right now is centrifugal pump. Then meron din siyang rotor or impeller nga. Ito yung rotating element ng machine usually consisting of a number of vanes and plates. So yung casing naman yun, yung closure, you can consider that as stator. It's yung fixed part ng machine. Then additionally, I will show you what is the example of an action flow machine. So yung rotodynamic machines, it can be considered or it can be classified into two types, radial flow, axial flow. Then may tinatawag pa tayong mixed flow pump. I will show you later. So for now, ano ba muna si axial flow? So this is an example of an axial flow pump or an axial flow machine. So meron din siya impeller kagaya nung kanina kasi nga it is a characteristic or it's part of a rotodynamic machine. Dapat may impeller ka at meron kang stator. So ang difference niya kay radial flow pump, in axial flow pump, the fluid will move in actually towards the vanes. Kagaya nito. So mapapansin natin, the best example ng axial flow is the turbines, water turbines or air turbines or simpleng ating fan. They operate in the principle of axial flow machines. Then lastly, yung ating mixed flow pump or yung combination ng axial flow and radial flow. So additional type of protodynamic machine is the mixed flow pump. Mixed flow pump siya yung combination ng radial flow at saka ng axial flow. So on the left side, it is the centrifugal pump, while on the right side, it is the axial flow pump. So let's go back to our presentation. That's it for the types of or classification of fluid pumps according to its operation, or classification of fluid machines according to uh, principle of operation. So again, according to principle of operation, we can say that for turbines, the work is done by the fluid on rotor. Then for the pump, compressor, fan, or blower, the work is done by the rotor naman on the fluid element. So ito yung types ng or classification ng fluid machineries. Overview lang naman to. So compressor, we can We can classify it as compressor and pumps, then turbines, then is it an axial, radial, or mixed flow. Then we'll move now to the classification based on the fluid use naman. So it's either gas or vapor, then liquid. So the fluid machines use liquid or gas as the working fluid depending upon the purpose. So na-explain ko nga kanina, depending on sa kung ano yung hinihingi ng end user or kung ano yung hinihingi ng industry, gumagamit tayo na kung siya ba is liquid or gas as the medium ng ating fluid. So pump are machines transferring the mechanical energy of rotor to the energy of fluid when it uses liquid. So when we say pump, definitely we will use liquid there. Then when we say compressor, fan or blower, we're gonna use is gases or in a common form is air. Compressor, sa industry, usually ginagamit lang naman is air. Hindi na tayo masyado nagko-compress kung ano man other type of gases pa. Pero when we say compressor, mostly talaga is air lang yung ginagamit natin dito. Same with fans and blower, since ginagamit sa HVAC, air lang naman ang medium nito, yung fluid na ginagamit natin para dito. So for compressor, it is a machine where the main objective is to increase the static pressure ng gas. Depending sa application, kailangan natin na mas mataas na pressure ng hangin to inflate ng gulong or to use for cleaning in any industrial or any machineries natin. For fan or blowers, mainly cause a high flow of gas and hence utilize only the mechanical energy of the rotor to increase mostly the kinetic energy of the fluid. So, pinapataas lang ito yung velocity niya ng fluid. In these machines, the change in static pressure is quite small. Wala halos daw change in pressure dito sa pag gumagamit tayo ng fans or blowers. Kasi nga, depende sa anong application na meron talaga dito. So water turbines or hydraulic turbines, the liquid used by the turbines to produce power is water. Wala akong masyadong alam na water turbines dito sa Pilipinas kung saan naka. Pero for steam turbine, sa norte or sa south naman is to makikita dito sa Guimaras. So turbines handling gases in practical fields depending upon whether they use steam or gas or mixture ng air and product of burnt fuel in the air. So mixture of air and products of burnt fuel in the air. Sa combined cycle natin yung makikita. So steam turbine uses steam. So ito yun. Or gas turbines. So that's it for the overview ng fluid machineries. Classification of fluid machineries. Depending on energy conversion, if it's a pump or if it's a gas or liquid or water. So those are the concept and theories behind fluid and machineries involving fluid. So pag pinagsama natin sila, so for example, sa gas turbines or sa pumps, gumagamit tayo ng pipe para may connect yung fluid machinery na to towards the source o para magkaroon ng passageway yung fluids papunta sa ating machinery. and it is in a form of the pipe. So the whole system, yung pag-aaralan natin dito, including the passageway ng fluid. Mainly pipes lang to, pero there will be a part here na madi-discuss natin na hindi lang naman pipe yung pwedeng daanan or pwedeng gawing passageway ng fluids. Kagaya ng ductings, hindi naman siya pipe, it's in a form of rectangular or square shape. So there will be another equation for that. But we will dwell much into this definition or the use of pipe as a passageway para sa fluids natin. So when we discuss the fluid flows in pipe, we need to discuss as well the principles governing those fluid flows. The first principle is the continuity equation. So what does continuity equation means? This principle is derived from the fact that the mass is always conserved in fluid system, regardless. Let's take note of the word conserved in fluid system, regardless of the pipeline complexity or direction of flow. So what does it mean is that the mass at point 1, here at section 1, will have an equal mass at section 2. Or we can say that there will always have a constant mass between 2 points. So M1 here will be equivalent to M2. That's continuity equation. So for compressible fluid, like I said earlier, compressible means siya yung mga gas or air. The equation for that, or the principle or the dimensional analysis for that is that the density ng fluid at point 1 multiplied by the area at point 1 times the velocity of point 1 is equivalent to the density ng fluid at point 2 multiplied by the area at point 2 times the velocity of point 2. So kapag binigay sa problem is diameter, binigay sa problem is diameter 1 and diameter 2. Makukuha naman natin yung value ng area ng pipe kasi ang pipe natin will be and will always be in circular shape. So, area ng pipe is equivalent lang naman siya sa area ng circle, which is equivalent to pi d squared over 4. Or we can simply say pi r squared. So, okay na tayo dito. Now, for incompressible fluid, such as water, ang formula naman niya dito, since siya is incompressible, is area at point 1 multiplied by velocity at point 1 is equivalent to area at point 2 multiplied by velocity of point 2. If we will analyze this equation again, area at point 1 multiplied by velocity at point 1, area at point 2, which is denoted by the symbol Q. So Q1, volumetric flow rate at point 1 is equivalent to volumetric flow rate at point 2. So ano yung magiging unit ng volumetric flow rate? Since area is in meter squared, velocity is in meter per second, then ang unit na mayroon ng volumetric flow rate will be in cubic meter per second. volumetric flow rate means gaano kadami or anong volume ng fluid ang dumadaan sa pipe per second natin. So kapag binigay sa problem, value ng volumetric flow rate, so makukuha natin ang value ng area by using this formula. Q is equivalent to A and B. A multiplied by B, or area multiplied by velocity. So kapag binigay naman sa problem is diameter, then makukuha din naman natin yung value ng volumetric flow, then multiplying it by the velocity. Then makukuha natin ang value for the volumetric flow rate. There's another way to get the value for the velocity. We have an equation for that later. So the second principle governing the fluid flow in pipes is what we call the energy equation or the Bernoulli's equation. So Bernoulli's equation is the relation between the pressure, kinetic energy, and gravitational potential energy ng fluid. So recall lang muna tayo what is Bernoulli equation. So Bernoulli principle states that the total mechanical energy ng moving fluid comprising the gravitational potential energy, this part in the equation, gravitational potential energy ng elevation, the energy associated with fluid pressure, so this part of the equation, and the kinetic energy ng fluid motion, this part of the equation. Fluid motion is velocity, this one is pressure, and this is the elevation, remains constant. So ulitin ko lang, the total mechanical energy of the moving fluid comprising the gravitational potential energy of elevation, energy associated with fluid pressure, and the kinetic energy of fluid motion remains constant. So this side of the equation, which is denoted by energy in, says that equivalent lang daw siya. The other side of the equation, or the energy associated with fluid pressure, the kinetic energy ng fluid motion, at saka ng potential energy of elevation are the same lang or equivalent. And two, Bernoulli's principle or Bernoulli's equation has two types of form. As you can see here is in the pressure. So ng fluid multiplied by velocity squared over 2 will always give us the unit of pressure, which is Newton per meter squared. Then same goes with the potential energy of elevation in a formula of density multiplied by the gravity multiplied by height. It will give us Newton per meter squared. However, there is another type of form of Bernoulli's equation which is in head form, like this one, the second equation. It will give us a unit in head or in meter. Actually, mako-convert naman natin tong first part na to, or it can be transposed into this part by dividing each side of the equation by the specific weight. It will give us or will into meters only. Bernoulli's equation, actually Bernoulli's, but it will induce additional factor here, which is called the head loss, or denoted by H sub L. Here is head loss. So equal pa rin naman sila. There's still a conservation of energy here. We're in the energy at point 1 given by the pressure head, velocity head, and the static elevation or hydrostatic elevation is equivalent to pressure head at point 2 plus velocity head at point 2 plus the potential elevation at point 2. Ngayon, para mag-equal sila, nag-introduce nga tayo ng additional na unit which is the head loss. So, satisfy pa rin naman si Bernoulli's equation, yun nga lang mag-a-add tayo ng head loss. So, what is head loss? I-define naman natin yan later. Pero, to give you an overview, head loss is the energy loss kapag ang fluid is nag-travel throughout a piping system. There are two types of head loss in some piping system. What we call is the major head loss. The first one is the major head loss. Ito yung pag-aaralan natin ngayon. And the other one is the minor head loss. So major head loss, kagaya na sinabi ko, ito yung parang frictional losses to within the pipeline. Since yung fluid natin is viscous, yung fluid natin is dumadaan or kumakapit sa internal diameter ng pipe, nagkakaroon ng losses, nagkakaroon ng frictional losses. And malaki yung nababawas na energy dahil dito, kaya tinawag siyang major loss. So ano naman yung minor loss? Minor loss in a piping system is due to the passage of the fluid papuntang fittings, iba't ibang fittings ng pipe. Kung may idea kayo sa fittings, mas maganda. Kung wala, ito yung mga tinatawag natin ng mga elbows, reducers, then valves. We consider that as fittings. So kapag ang energy loss, so fittings are essential sa isang piping system para ma-direct natin, para ma-control natin ang movement ng fluid. So elbows are used to redirect or ibahin ang direction ng fluid. Same goes with kapag gumagamit din tayo ng valves para ma-prevent or ma-stop natin or ma-regulate natin yung fluid flow. So yung head losses caused by those fittings, we call that minor loss, while those head losses caused by the frictional losses ng fluid sa internal diameter ng pipe, ang tawag naman doon is major head loss. Yun ang pag-aaralan natin on this topic. So kapag may involvement ng fittings, minor head loss yung kukunin natin. Kapag wala, ang kinukuha lang natin is within the pipe segment, major head loss yung kukunin natin. Then when we discuss about head loss, we need to discuss about the viscosity ng fluid. Yung relationship ng viscosity ng fluid sa internal roughness surface ng pipe, yun na nagkakos ng head loss. So, for the viscosity ng fluid, meron tayong tinatawag na dalawang klase or dalawang type ng flow. Actually, tatlong type yan. The first one is laminar flow. Second is the turbulent flow. And the third one is the transition flow. So kung makikita niyo yung progress ng ating topic, we started first with the major topic, which is what is the head loss. Then, i-define natin according to roughness ng pipe wall. So viscous effect ng mu, everything is for the fluid flow lang, about lang to sa fluid na dumadaan. So laminar flow and the turbulent flow, and in between is the transition flow kasi there will be no way na after laminar flow, immediately it will be turbulent flow. Walang ganun. There will always be a transition in between. So let's define first what is laminar flow before we move to Reynolds number. So laminar flow is characterized by fluid particles following smooth paths and layers, with each layer moving smoothly past the adjacent layers with little or no mixing. So in common term, laminar flow daw is yung smooth flow or moving on a straight path only. while turbulent flow is characterized ng chaotic changes in pressure and flow velocity. So before we move with Reynolds number, I'll show you a video of types of fluid flow para mas ma-visualize natin to. So okay, here it goes. So as you can see here, laminar flow is represented by a smooth motion of the fluid inside the pipe. It moves in a single line or straight line only, and there's no chaotic behavior na nangyayari within the flow. Now I will show you naman ano yung turbulent flow. The turbulent flow is characterized by chaotic movement and mixing of particles. So technically, that's the concept behind the types of flow when it comes to piping system. It's either a laminar flow, turbulent flow, and in between those two, you can say there's a transition flow. So ano yung significance niya? Well, that's more of a theory lang talaga or yun yung fundamentals behind types of flow. Pero hindi naman siya masyadong ginagamit sa problem kasi ang kinukuha natin talaga is yung Reynolds number. So ano ba si Reynolds number? Reynolds number is associated with uh, ano ba yung flow na dumadaan sa piping system natin or ano ba yung flow na meron yung fluid natin. So Reynolds number is a dimensionless number that is used to determine the type of flow pattern as a laminar or turbulent while flowing through a pipe. So si Reynolds number, again, dimensionless number meaning wala siyang unit, as you can see here. It is the ratio of the forces of inertia, to define it, kung ano ba yung forces ng inertia, to the viscous forces, kinematics of the fluid. So to give you an idea lang, ano ba si Reynolds number, paano ba siya naging, ano ba yung significance niya. So kapag nakita natin na ang Reynolds number ng fluid is less than 2,000, then we can remember or we can determine na, okay, ganun pala yung flow niya, is in laminar or smooth flow. While if the Reynolds number is in 4,000, then maidi na tayo kung ano ba yung turbulent flow behind it. Then transition flow nga is between 2,000 and 4,000 Reynolds number. Again, remember, dimensionless number meaning wala siyang unit. So what is Reynolds number? It's an inertial force divided by the viscous force. So ano ba si inertial force? Inertial force, ito nga yung associated with the term inertia or momentum. So momentum forces are inertial forces. It's the force that keeps the fluid moving against the viscosity forces. While the viscosity forces or viscous force is a measure naman ng fluid's resistance to flow. So when we say about Reynolds number, when we say about the fluid flow, viscosity forces, resistance to flow, inertial forces, everything is related only to the fluid. Hindi pa dito or wala pa kinalaman dito yung piping material na ginagamit natin. Reynolds number is related only to the fluid flow. Another way to get the Reynolds number is using this equation, equation 1 and equation 2. So in equation 1, we need to multiply the density ng fluid to the velocity ng fluid times the diameter of the pipe. Divided by the absolute viscosity ng fluid. On equation 2, medyo parehas lang sila. Nagkaroon nga lang tayo, nag-introduce lang tayo ng additional type of viscosity, which is the kinematic viscosity ng fluid. So kapag binigay sa problem is kinematic viscosity ng fluid, then ang gagamit natin equation is yung equation 2. While if the problem provides the absolute viscosity ng fluid, then you're 1. So in equation number 2, to get the Reynolds number, we need to multiply the velocity ng flow times the diameter ng pipe divided by the kinematic viscosity ng fluid. So ano ba si kinematic viscosity at ano ba si dynamic viscosity muna? So kinematic viscosity is a measure of how much a fluid internally resists flow under the influence of no outside forces other than gravity. So ano naman si absolute viscosity? Absolute viscosity is equivalent to kinematic viscosity multiply by the fluid's density. Kaya kapag ang binigay sa problem is kinematic viscosity, nawawala na si density dito sa numerator. Kasi equivalent naman si dynamic viscosity sa kinematic viscosity multiplied by the density ng fluid. So additionally, there is another way to get or to solve for the value of velocity if hindi binigay si volume flow rate. We can use this equation to solve for the problem or to solve for the value of velocity. Velocity is equivalent to 2gh. But be sure na yung height natin is given as a kinetic head. Same lang siya dito sa Bernoulli's principle na to. Is part of the equation. Okay, then we can move forward. So to get the Reynolds number kanina, we need density ng fluid, velocity ng fluid, then the diameter ng pipe. So still pipe pa rin yung pinag-uusapan natin, divided by the absolute viscosity ng fluid. But what if ang given sa problem is a non-circular section, hindi daw ito pipe. Ductings, it's not a pipe, pero ginagamit siya to transfer the fluid, air, or gases from one section to another section. It's a passageway of gas, hindi siya pipe. So, paano natin i-compute or paano natin makukuha na yung Reynolds number ng fluid dito? So, Reynolds number ng fluid is equivalent to velocity ng fluid multiply 4R or the hydraulic radius divided by the kinematic viscosity ng fluid. So, it should be the diameter or equivalent diameter here. But since hindi siya, so equivalent diameter is equivalent to 4R, which is R is represented by the radius, and to get R, we need to divide the area into the wetted perimeter. So ano ba yung sinasabing area and wetted perimeter dito? Ito yung sa next slide. Hindi naman usually ginagamit ito sa problem or hindi natin ito usually na-encounter. I think nung board exam na hindi ko ito na-encounter before, pero for the sake of this lecture, sige lang, please remember na we need to divide the area given in the problem to the wetted perimeter for us to acquire the hydraulic radius. Then transpose it here, multiply it by 4, and we can use that to get the value of the Reynolds number. So even this is a circular section or circular channel, as you can see, hindi lahat ng area ng circle is nalagyan natin ng fluid. So pag ganito yung situation, ito yung gagamitin natin equation. Same goes with this one, and this one. Now we'll go to the major topic, the major head loss. So before we come up with the head major, we need to know muna ano ba si Darcy-Pritchett factor at ano yung relevance niya kay Reynolds number. So by definition, major head loss refers to frictional, ito nga yung mga frictional energy losses that is caused by the viscous effects of the medium in the roughness of the pipe wall. And then we can evaluate it using an empirical equation called the Darcy-Weisbach equation. Darcy-Weisbach equation, it just estimates the change in the pressure or pressure drop due to the friction in a pipe during a fluid flow. So again, it estimates the change in pressure or pressure drop due to the friction in a pipe during the fluid flow. So kapag kukunin natin ang major head loss, as you can see, major head loss nga daw is a frictional energy loss. And the best way to do that is to use the Darcy-Weisbach equation. Ito rin yung commonly used na equation na ginagamit. Ito rin yung kapag hindi binigay sa problem kung ano yung equation na gagamitin, mostly ito yung gagamitin natin, si Darcy-Weisbach equation. Pero may iba't iba pang klase ng equation na involved when it comes to major head losses. So when we say major head loss, there is a relationship between the viscous effects of the medium or the fluid flow and the roughness of the pipe wall. So isinasama na natin dito yung characteristic ng pipe na ginamit natin. Kanina, while computing Reynolds number, diameter lang ng pipe yung ginamit natin. Pero mostly talaga siya is about the effect of viscous effect ng fluid flow natin. Pero kapag major head losses, nagkakaroon na tayo ng interaction between the roughness ng pipe together with the viscous effect ng fluid. So to get the value for major head loss, we need to first acquire what is the Darcy friction factor. Length ng pipe, usually given naman yan. Flow velocity, na-explain ko naman kanina, if given si volumetric flow rate, if given yung diameter ng pipe, then makukuha natin yung velocity. If given si kinetic head, then makukuha din natin yung velocity ng flow. Length ng pipe segment, usually given nga, as I said, then divided by 2 GD, which is G is acceleration due to gravity, that's constant, and D, usually given naman yan, or makukompute natin as long as given si area, given si velocity, and given si volumetric flow rate. So how are we gonna acquire for the Darcy friction factor? Madalas naman, binibigay ito sa problem or given na si friction factor, or minsan ito yung hinahanap natin sa problem, si friction factor. So, okay. So, for us to get the friction factor, if hindi siya given sa problem, or for the sake of our understanding lang, kasi sabi ko nga, usually binibigay na sa problem si friction factor, or siya yung hinahanap sa problem, then kung for the sake of our understanding of our lesson, may tinatawag tayo Moody diagram. Dito natin makukuha yung value ng friction factor as you can see in this y-axis on the left side of the chart. So Moody diagram is a family of curves that relates to the friction factor, Reynolds number, ito yung viscosity ng fluid, and relative roughness ng pipe, or Reynolds number nga determines the flow ng fluid, and interrelationship with the relative roughness ng pipe, as you can see in this section. So when we say relative roughness ng pipe, what we're talking about here is the inside part ng pipe. So dito na ay nagdidepende, or ito yung characteristic ng material. So kung ginagamit nating pipe is carbon steel, stainless steel, or alloy steel, dumidepende rin yan sa kung anong thickness ng materialis natin. So I guess this is just an empirical value lang naman. Ibinibigay naman sa problem natin yan. Just in case ipapahanap. Okay, so Moody diagram, once again, is a family of curves that relates to the friction factor, Reynolds number, and relative roughness ng pipe natin. So, once available na si friction factor, then makukompute na natin si H major. Ang unit nito ng major head loss is in meter or in height. So, other formula to get for the value of the major head loss is by using the Morse formula. Halos parehas lang naman siya kay major head loss, kay Darcy-Weisbach equation, FLV squared over 2GD. Dito nga lang, ang equation niya is FL2V squared over DG. Yung number 2 sa denominator, nagpunta siya sa numerator. So, kapag sinabi na calculate the head loss using the Morse formula, then ito ang ating gagamiting equation. So, to get the F value or the coefficient of friction para dito, we will be using those two equations sa baba. So, kapag ikaw is laminar flow, we'll use this equation. So, coefficient of friction is equivalent to 64 divided by Reynolds number. While kapag ikaw naman ay turbulent flow, o yung fluid at turbulent flow, coefficient of friction is equivalent to 0.316 divided. So, sana clear tayo doon. Regarding sa major head loss, kay Darcy-Weisbach equation, at sa Darcy friction factor, and other parameters involved, kagaya ng velocity and Morse formula. Then as discussed earlier, napag-usapan natin yung direction ng energy conversion, tama. So kapag nag-introduce sa system ng pumps, kanina kasi pinag-uusapan lang natin is regarding sa piping system or on straight pipes or horizontal pipes, ano yung losses involved doon. Then so those pipes are connected on this part of the pumps. So kanina pinag-usapan lang natin yung fluid flow inside these pipes. But what if nagkaroon na ng interconnection between pipes and the pumps? Ano naman ang equation na nag-govern dito? Same pa din, it will be the Bernoulli's equation. But instead of introducing one parameter only, which is the head loss, we will introduce now additional parameter, which is called as work in pump or pump work. So based sa direction ng energy conversion, energy in will always be equal to energy out as per Bernoulli's theorem. Then head loss will always be part of energy out kasi ito yung mga frictional losses o yung mga wastage na energy due to frictions. Ito yung mga nasasayang since this is not an ideal world. Laging meron tayong frictions and head losses. So part pa rin siya ng energy out. Then ang nadagdag nga lang is yung energy in into the system, which is pump, work in pump or WP. So it will be part of the energy in. Bakit? Kasi as explained kanina, ang purpose ni pump is to add mechanical energy or to add energy into the fluid flow. So papasok yung energy dito sa fluid, kaya nandito siya sa first part or left part ng equation. So to complete the equation with the pumps, so it will be the kinetic head at point 1 plus the pressure head at the inlet plus the static head at the inlet now plus the work in pump WP is equivalent to the kinetic head on the outlet plus the pressure head on the outlet plus the kinetic head, hydrostatic head on the outlet plus the head losses in the system. So it will be in a unit of head, which is in meter. Now, iba naman pag sinabi sa problem is turbines. So, based on the direction of energy conversion, in turbines, both the head losses and the work in the turbines will be on the second part on the right side of the equation. It will be part of the energy out. So energy in will still remain the same. If meron tayo ditong passageway ng fluid, same goes here. If may passageway dito ng fluid, so yung fluid na pumapasok dito sa ating turbines will have its own velocity head at point 1 plus pressure head at point 1 plus the hydrostatic head at point 1 is equivalent to sa energy out naman, which is the velocity head of point 2 or the outlet plus the pressure head of the outlet plus the hydrostatic head. Ngayon, head loss, still we have head loss kasi there will always be a losses in a system no matter what happens. Plus the work out of turbine. Bakit napunta sa energy out si work ng turbine? Unlike sa pump, wherein yung pump ang nag-provide or nag-i-input ng energy sa fluid, sa turbine naman, yung fluid ang nag-provide ng energy dun sa turbines. So, ang ginagawa ng fluid, kino-convert yung kanyang energy, pressure energy, kinetic energy, or hydrostatic energy into the works of a turbine para mapagalaw or mapaikot yung generator, yung nakakouple ng generator. So, dapat malaki yung value ng work ng turbines dito. Kaya napunta siya sa part ng energy out. Siya yung palabas na energy sa system, hindi siya yung papasok na energy sa system or sa fluid. Okay, so may tanong ba kayo before we move to sample problems? Okay, so let's have a break muna, around 15 minutes. Ise-set up ko lang yung ating Jamboard. Okay? Can we resume at 3:50? Then please join sa Jamboard natin pamaya around 3:50. Thank you.